Hi everyone and welcome to this new video in which I continue my Linux Privilege Escalation series. In this episode in particular we will talk about Linux reverse shells. So how to spawn reverse shells in Linux, some basic payloads, some basic theory on the difference between reverse shell and bind shell. So this is an important episode for the Linux Privilege Escalation series because when you get onto your target, when you get some kind of remote code execution into your machine, the first thing you want to do to establish a proper foothold is to spawn a reverse shell, and then later on you can do actual privilege escalation. So it is a really important step. I hope the video is enjoyable. If you have any feedback, please leave it in the comments. Let me know what you think of it. And that's it. Enjoy the video. So first things first, in terms of the setup we will use, we'll have a Docker setup. So we have a Docker file, a simple Docker file with really like just some basic commands that I install into the machine with some basic user. We don't really care much about this Docker setup. What we care about is just building the Docker file. So with docker build/t, actually I need to become root. So I build the Docker file, it is already built actually, because I've already done this. Then I run the Docker, I'm running the Docker, and now I can execute a shell in it. So a basic bin bash shell. So now we are inside this Docker, so we are not currently in a ROS, we are inside the Docker, and all the payloads that I will discuss will allow us to obtain a reverse shell within this Docker. Of course, this is simulating a scenario where we have a client, like an attacker machine, an attacker box. The attacker box has managed somehow to obtain a code execution into a remote server, maybe through RCE, remote code execution, and the next step after you obtain RCE to properly enumerate and do privilege escalation and all of those stuff is to establish a reverse shell. So you want to establish a reverse shell between your attacker machine and the server. So we will see various methodologies, various payloads that allow us to do exactly this step. So we'll consider the Docker as if it's the server and our host machine as if it's the client. So that's the idea. Now to start off, we can discuss the difference between reverse shell and bind shell. I've already discussed this difference in the video on Windows privilege escalation, but since this is a distinct series, it talks about Linux, I'm gonna repeat it again so that if you just follow the Linux privilege escalation, you will have all the required knowledge. This is because regardless of the system you're in, if you're in Linux or Windows, the idea of a reverse shell is the same, and the difference between reverse shell and bind shell is also the same. So what's the idea here? When we obtain a code execution onto a vulnerable system, the first thing we have to do is to spawn a shell. Now, why is this the case? Well, because typically, the way we obtain code execution through a system can be very complex. For example, if you are exploiting a web application using the HTTP protocol, in order to obtain our remote code execution, we might have to send a lot of different HTTP requests, and the flow of those requests can be complex, the information flow, the data flow. So it might not be easy to just repeat it all the time to execute new commands. So what's the idea? Well, we obtain first remote code execution and then we use that remote code execution to obtain a proper shell, a proper remote shell, of course. Remote because we are not obtaining a shell in the system we are using. For example, here I am in my system and I have a normal shell here in the background, here in the beneath buffer. This is a shell, I can do commands, but these commands execute within my local system. If we want to attack a server, we want to obtain the same idea, the same shell, but in the remote server. So it has to be a remote shell. So the idea is we use the remote code execution to trigger the remote shell, and once we have the remote shell, we will be able to execute any command we want directly through an interactive remote shell. So that's the idea. Now, to actually obtain this remote shell, there are two different techniques. One is called the bind shell and the other is called the reverse shell. So what's exactly the difference between bind shell and reverse shell? In the bind shell scenario, the attacker forces the vulnerable compromised server to open a port and to listen for incoming connection. So the compromised system acts as a server while the attacker machine acts as a client. So in this case, the compromised system opens a port and we connect to that port. This is the idea of the bind shell. Because of course to do this connection we need to do typically a TCP handshake, so we need to establish a TCP channel between the two endpoints, and during a TCP channel installation, like when we establish it essentially, one of the components has to be the server listening for incoming connection. So in the bind shell scenario, this component is the remote server, the compromised system, the system we want to attack. This of course is different with respect to reverse shell. In a reverse shell scenario, who actually listen is not the compromised system, the compromised server, but rather it is the attacker machine. So we have the attacker that listen on a given port and on a given IP address. So it listens on a given TCP IP endpoint in the internet that is publicly accessible from all the servers in the internet. And then the compromised system actually connects back to our attacker machine. So the big difference here is that now who's doing the listening is not anymore the compromised system, but rather it is our attacker machine. So the attacker machine now acts as a server with a public IP on a public port on which it listens for incoming connection, while the compromised system acts as a client. And this brings us to the simple reason why most of the times reverse shells are better than bind shells. So, since using reverse shell, the connection is outbound, which means that the compromised server simply makes an outbound connection towards the public internet, it is much harder to recognize that as a malicious threat, as something that is malicious, that is weird, that has to be examined more thoroughly. I mean, it is typically okay to connect to the public internet, while it is much more dangerous to open a port in your network infrastructure to listen for incoming connections. I mean, I'm not saying that outbound connections are not also monitored for sure. You also, if you have, for example, a company network, you might be cut from accessing directly the public internet, but assuming that your laptop, that your computer can access the public internet on its own, then you will have a lot of outbound connections, while you will not have many inbound connections, that is connection in which you are the server, in which you open a specific port. So in both cases, I mean, the idea of having a remote shell is the same. We want to have remote control over a shell process, but the way in which we do it is like the party, the entity who listens and the entity who connects to the listener changes, and this is why typically reverse shells are better. Another reason that also has to do with networking, it's the position in the networking, is for example, suppose that you have a NAT system. So in a NAT system, you have your LAN with your PC, so PC1, then here you have your router, so this is like a router, and here you have the public internet, right? So in a NAT scenario, in the public internet, you do not actually go with your specific IP. Rather, you go with the public IP of the router. So it means that when someone wants to connect to your port here, it actually has to go through the router, and by itself, by default, in most configuration, this connection does not happen directly. If I open an endpoint with IPM port, and from the public internet I connect to that specific port and the public IP of the router, of course the router will not know that this package has to be actually delivered to this particular computer, because there could be other computer listening. So there has to be a specific router configuration which allows for inbound traffic and which allows for the routing of said traffic. Because the router has to understand, like, okay, if you listen on port 444, you have to route it to PC1. But if you listen to port 555, you have to route it to PC2. And all of this to say that when it comes to inbound connection, it is much more difficult to get it right especially when you're doing like a penetration test, when you're checking out the security of a system, because it's just much more difficult. So for all these reasons, a reverse shell is always better because you just do an outbound connection. Although, as I said, this does not mean that the connection is not monitored. If you have a firewall, if you have a web application firewall, or just any firewall that looks at the packages, all your payloads might be intercepted and analyzed. So you might want to use a reverse shell that uses cryptography to hide, to encrypt the payloads, but that's for another story, that's for another day. So all of this to say, reverse shells are always better. Now, before actually showing how to do this, the actual payloads to spawn a shell, so we have our lab here. Here we have our machine within the Docker. So this is within the Docker. And then down here, I have my shell within the attacker box. So I have this setup. And here I can just bring back the nodes. So I will actually show how to do file transfer between your attacker machine and your victim machine. Now, why is this useful to know? Because sometimes to spawn a reverse shell, you want to approach it in multiple stages, where in the first stage you write a file to the server, and in the second stage you execute that file. So if you have a remote code execution, it can happen that maybe that remote code execution is not too stable, so you don't want to do it in just one command, you want to split it out. And so it might be useful to know how to transfer commands from the victim to the machine. So to transfer commands, there are two things you have to do. First, on your attacker machine, you have to start a local HTTP server that is also, of course, accessible from the victim machine, which means that if you are connected to the victim using the internet, this web server has to be publicly accessible, otherwise it doesn't work. In our case, what we can do is, let's create here a folder called www, and in this folder I'm gonna write a bunch of stuff. I'm gonna write touch test.txt, and in this test.txt I'm gonna write, so let's go down here, please subscribe guys. So I write this file, then I open a local web server, so I say python3-m to access the modules of Python 3, and then I say http.server, and then the port I want to listen on, which is 1337. So I open the server, and now I'm listening to the server. Now, of course, I go back to the victim machine. Now I am on the victim here, and I'm assuming that I have my remote code execution. So I'm able to execute commands within this server. Now I'm doing it directly with a shell, so I already have a shell, but assume that this shell is just simulating my ability to send remote commands to the server. So for example, one command I can use is curl. Because I have curl installed, I can use curl, and I can use curl specifically to connect to my server in order to get the data. So let's say that I do curl, and then here I have to put HTTP and the IP address of the attacker machine where the web server is listening on. How do I get this IP? In my case, I can just assume that since I am on Docker, I can just grab all the interfaces and grep for Docker. And notice here what do I get? I get this IP address, which is the IP address of the Docker interface. So I'm just gonna do this. I have to put the port, of course, 1337. And let's say here I do test. So I'm trying to access the resource test on my web server. I do this, and notice what happens here. Here I get a not found, a 404 file not found error in HTML, thanks to the command line curl, and here in the log I get, look, someone has tried to obtain the /test file, but we do not have it, so I return a 404. So what's happening here essentially? The idea is that I'm using curl, which is a command line utility to perform HTTP queries. And the idea is that we want to use the HTTP protocol to transfer files between the victim and the attacker machine. Because HTTP is one of the most used protocols, it's very useful. There are a lot of command line tools for it that are very simple to use. And the way I use it, it's simple. I just say curl, I put the URL which specifies the resources. This is attack control. And then I can either let it print on the standard output, or I can just redirect this thing into a file. So I can say like this, redirect into test.html. So I do this transfer, and then in test.html I have the response, which of course in this case it does not exist because I have no file in this folder that matches the test name. It's actually called test.txt. So we make another query, and this time we're going to do test.txt, and we're actually going into test.txt file. And notice this. Now in the log, it does not say anymore 404 not found, rather it says 200, which is the status code HTTP that says, okay, all good, you have your file. So the web server running on my attacker machine has actually correctly transferred the file over to the victim machine. And now, if we check the files here, notice this, test.txt has 18 bytes. If I get out the content, I have my please subscribe. So it actually works. So that's the idea with file transfer. Of course, you can do it with multiple commands. You can use curl, which is a very famous command line. You can use wget, which is another command. And with wget is similar. You just do wget, then you put the URL, and then you put a big O, like dash. So you do wget. I think here is dash O, like minor O. Let's see if like this. Let's remove the test.txt to make sure that we actually download it properly. Test.txt. Okay, no, it's not minor. I think it's capital O. So dash capital O. Okay, that means this makes sense. And notice that now I've actually downloaded the file. So I can go into TMP. I can do it again. Here I have now my file with 18 bytes correctly. I get the output, and I have please subscribe. So here I just show two simple commands, curl and wget. Of course, the command you use here depends on the binaries that already exist on the victim machine, on the target, on the server you're trying to attack. Because if you go into a server and you already have curl there, you can just use it. You can just use it to do file transfer. If you have wget there, you can just use wget. Finally, here I show Perl, like if you have Perl, you can do this. Because sometimes it has happened to me that in the machine I was in, I did not have curl, I did not have wget, but I did have Perl. So it's a very similar way. You just have to change here with the attacker payload, with the IP address of your attacker. So the IP address we said was, let's remember here which one was it. It was this one with port 1327 test.txt. And then we can go here and we can just change it up here. It's the URL. The URL specifies the resource we are interested in. Then we take this command. We go here. Let's say which Perl to make sure that, look, Perl is actually installed. Let's check if we can use this payload. So notice this. Once again, we obtain a different request here. And actually, no, this time I use it with in my own host. So look at this. I use it in my own host, so it doesn't make sense. Let's do it again. But this time, I'm going to make it on the actual Docker. So here I'm on the Docker. I do this Perl. Notice I get 304. Okay, this is interesting. And what if... Okay, please subscribe. So I get a 304, and then I get please subscribe. So I get the actual file. Actually, let's see if I delete it, if it actually downloads it. Okay, it actually downloads it properly. That's good. So this is another command that you can use anytime you're on a system. Perl is typically installed as a binary. Otherwise, you have curl and wget. Of course, I suggest the first two. This is just in case if you don't have neither curl nor wget. And this covers the file transfer commands. So suppose that you are able to transfer files into the remote machine. How do we actually spawn a reverse shell? So in the video I made on Windows, I showed how to spawn a reverse shell using the command line cmd.exe and the PowerShell. So different payloads for different languages. Well, the idea is that as long as you have an interpreter of commands, you can have different reverse shell payloads. Because at the end of the day, anytime you have an interpreter, like a Bash interpreter, or a Python interpreter, or a Perl interpreter, or a PHP interpreter, or a Ruby interpreter, you can also have compiled languages, like compile like C, C#, and things of the sort. Anytime you have a toolchain which allows you to write and execute code, then you have a different reverse shell payload. What's important here to understand is that these tools have to be installed on the server you're trying to attack, you're trying to test. Because if you don't have those tools, you cannot spawn a reverse shell. The idea of a reverse shell is you're gonna listen with your attacker using netcat. This is your attacker. And then using your victim, in the victim, you're gonna trigger some code using, for example, bash, or you can use Python, or you can use other tools to attack to your attacker, to connect to your attacker. And the way you connect depends on the language you choose to use, essentially. So let's try, for example, this first bash payload. So the first payload we use is this one, this bash-c, and then in the string we have bash-e, then all of these other commands. Now, if you're interested in understanding the exact working of this command, I have a video linked in the description made by 0xdf. It's very fascinating because it goes into in-depth detail explaining this single payload. I'll just leave you to that video because he made it really, really well. So if you're interested in like knowing internally, okay, what are all those things, it can be really helpful to learn how Linux works. For our purposes, we're just doing privilege escalation, so we will just use it without understanding it in a black box way. Because remember, sometimes it's useful to be able to abstract, so you just use it, but at the same time, never forget to take your time and understand how these black boxes really work. And maybe in the future, I can make something along those lines of explaining in depth this kind of command. But there's already a video about that, so I don't really think I need. So how does it work? How do we use it? Well, we take this payload, very easy, very easy. Now, at this point, we can remove the web server. So we can totally remove the web server. We can just focus on the attacker machine and the victim machine. So we have attacker machine and victim machine. So in the attacker machine, we're going to use netcat here, NC, this is called netcat. It is a program to interact with TCP channels to listen on a particular port. And I'm going to use the 4321 port, and here these flags are L, V, and P. In particular, L is for listening, P for specifying the port to listen on, and I think V is for verbose, and N, currently I don't remember, I think it's for not translating IP addresses or something like that. Anyways, we're just gonna do this command. Notice that I press OK, so I sent the command on my attacker machine, the one down here. So this one is my attacker machine, and now in this app one, which is the victim machine, I'm gonna execute the payload. Now, what's important to understand about this payload, to truly understand it, is that this payload contains some structure that remains the same, and then is parameterized by two different things, which is the IP address of our attacker machine and the port on which the attacker machine is listening on. So the IP address, this one, is the IP address of this machine, and the port, as you can see, is the port that I'm listening on. So once I do this, notice what happens. I execute this command on the victim target, and then look at this, connection from a certain IP address, and here what do I have? I have a bash shell, and here I can say who am I can say hostname, I can go into the root directory, and I can execute my commands. And this would work even if I was exposed to the public internet, assuming, of course, that there is no problem with network latency, delay, and stuff like that. So the idea is that I listen on my attacker machine, I execute the payload on the victim machine. When I execute this payload, I trigger the reverse shell, because at this point, the victim machine connects back to my attacker machine, so he is doing outbound traffic, and I get control over a bash process that is running on the victim. So here on the victim, a bash process is running, and now I have remote control over it. So that's the idea, and it's gonna work with all the different payloads. So the only thing that changes here, I can, like, for example, stop this, and I'm gonna stop it like this, and I can get back to the setup as before. So the only thing that changes between these different payloads is the program we use to trigger the reverse shell. But notice that all these programs, in their different ways, each one with its own syntax, they essentially do the same thing. They start a process, the bash shell or the sh shell, so they start a shell process, then they connect to our endpoints using a TCP connection, and then they redirect the standard output of the shell process into the TCP socket. So essentially, the way it works, if you just analyze all this code, is you have a TCP connection. Of course, all of these different programs, they deal with TCP connection differently. For example, in Bash, you have this reader /dev/TCP. This is how you connect. This is like a device driver of the Linux kernel. In Python, you have the system call socket.socket. In Perl, you have the socket. In PHP, you have the fsock open. In Ruby, you have the TCP socket open. So you always deal with a TCP socket. The next step is to start a shell process. And in this case, for example, this is the bash.i. This is how you start. Or here it's essentially the subprocess call bin.sh, or here is the exec bin.sh and things of the sort. And then you redirect the output into the socket, into the TCP socket. So the idea is that this can happen before or after you execute the program, depending on the programming language. So for example, here you do the execution at the same time, essentially in Ruby. So the idea is that after you have executed the program, or right before executing a program, you want to connect the standard output of the program to the TCP socket. So at this point, you have essentially exposed your process to the TCP socket, which is controlled by attacker. Therefore, you have exposed your process to the attacker. So that's the idea. So this was with Bash. Then there is this other payload with Python. So we can try it the same way. We listen with the attacker machine. We paste this. Just make sure that the IP and the port is the correct one depending on your attacker box. And boom, we have a connection. Now notice that this time we don't have a full shell. We just have an SH shell, because here we're just running SH, which is a bit less powerful than Bash. And to actually upgrade to a full TTY, we can actually use this command, which is Python 3 -c import pty pty spawn bin bash. So this command essentially transforms our semi-working shell into a full-fledged TTY, and it uses the pty.spawn bin bash. It uses a Python library. So here we are abusing the fact that this Python library exists everywhere, and it's extremely useful for these sort of things. And now, once again, we have a full working shell. We can do anything we like. We can go into a root directory. We can do stuff in there. We can get a flag. We can elevate our privileges, and so on and so forth. So for example, with respect to this Python, so this Python shell, we can analyze this as follows. So this Python 3 -c is simply to execute Python from the command line. So the real Python that we execute is this. So we import three libraries, the socket, the subprocess, and the OS. We create a socket. We connect to the attacker. We duplicate the standard output, standard input, standard output, and standard error to connect to the socket standard input, output, and error. And then finally, we call the subprocess bin.sh. So let's say that we save this into shell.py. So we have saved this into an external file. And then, so this is our attacker. Actually, where is it? I think it's here. What about here? Okay. So we have this shell.py in our www. So let's say that we want to spawn our reverse shell in two different steps. So the first thing is going to be download this malicious shell.py into the remote target, and then we can execute it. So how do we do it? First, we can just start our web server in the www. So as follows, Python 3 -m HTTP server 1337. Then within the victim machine, we do curl. Then we put our IP address 172.17.01.1337, shell.py, and we redirect to the current directory. You can also redirect to /tmp/shell so that you know exactly the full path. This is really important, because after this, you listen with netcat to a port, and you just do Python 3 tmp shell.py. It's gonna be, so there is a problem here. There is a string problem. So I wrote it wrong. I made a mistake here. Can happen. So I'm gonna, because I have a string literal that is not needed, so I remove this. And once again, I'm gonna transfer the file. I have to transfer it again, of course. And then I'm gonna execute it. tmp shell.py. And notice what do I get here? Once again, I get a reverse shell. This is a simple SH shell. To expand it, I can use the upgrade technique with import pty, pty.spawn bin bash. And now I have a full pty, so now it's a full shell that I can use however I want. So to finish off the video, the only three payloads that we need to see are the Perl, PHP, and Ruby, but essentially it works the same way. So assume that I can remove this, exit here, wherever. So let's listen to netcat. Here, this is the Perl payload, like this. So I execute it, and once again, I have a shell, and then I can upgrade it, for sure. Then we have the PHP. I mean, they all work the same, really. It's just different interpreters, different languages, but at the end of the day, what we really need is to work with that TCP channel. So we have the PHP. So of course, here I have to put the right IP address. If you put the wrong one, it doesn't work. 014321. Notice, once again, I have a reverse shell, and I can upgrade it as follows. So remember that these are all different code, they look different, but at the end of the day, they still establish a TCP channel, they call a process, and they connect the process to that TCP channel. And finally, we have the Ruby payload. So here, let me fix the IP address with 17014321. So this is the Ruby. Let's see, of course, if Ruby is installed, because maybe Ruby is not installed, but it is installed, of course. So I copy this payload, I bring it here, and I get the bad file descriptor. So I had some problem with the previous Ruby payload, then I found this website, I think it's this one, should be this one, and this reverse shell cheat sheet, I'm gonna put it into the description of the video because it's useful. And so like refs, I'm gonna put it here. And I found this other website with Ruby. So here it's listed for every programming language, the way to obtain a reverse shell with that specific programming language. We can take the second payload. I've just changed the IP address here. And notice here, I just listen with my netcat. I paste it here. And then notice that once again, I have a reverse shell as root because I'm executing on the container. Again, I can upgrade it. Can I upgrade it? Oh, I don't think I can upgrade it apparently. So this one is not working as before. So let's see. So sometimes these reverse shell are not too stable. So I got this reverse shell. Maybe I cannot upgrade this one, but it still works enough to obtain the stuff that I need. So that's the general idea, essentially. So the general idea is that a reverse shell allows us to transform a remote code execution into a remote shell on the system we need to test out, maybe in a penetration test or stuff like that. And there are different payloads for reverse shells depending on the programming language you use. Now, they might seem really different from each other, of course. I mean, just look at this last Ruby code. But the idea is that all of these payloads, and even the one in this guide, like here there are even more languages, it's just there are a lot of different languages. Well, all of this payload, in one way or another, they do the same things. They establish a TCP channel, they start a process, a shell process, and then they connect the shell process to the TCP channel in order for you to have remote control over a shell process. So that's it for this video. If you obtain remote code execution, the first thing you should do is do file transfer, check if you have the commands to do file transfer. If you have transfer some reverse shell payload or execute it directly, for example, the Python, you can try to execute it directly. If that does not work, then you can put it into a file, transfer into the machine and execute it with Python as I showed before. And then, depending on the program you have on the remote machine, you can use different reverse shell payloads. So I hope it was interesting and useful. Leave some comments, leave some feedback, and subscribe to the channel, and see you to the next video.